So the second example that you'll have in your notes is about a baker who's selling donuts. It says a baker earns 15 cents profit per glazed donut G, we'll talk about the parentheses in a minute, and 40 cents profit per jelly donut J. If a customer wants to buy no more than a dozen donuts and wants to try at least one of each kind, what is the maximum profit the baker can earn? Okay, so the parentheses, you're allowed to use any variable you want when you are doing linear programming. I just prefer to continue to use X and Y. So even though they told me G for glazed, J for jelly, I'm just going to write X equals glazed, Y equals jelly. And I'm going to still use Y and X because it's just easier for me. Okay. So again, we're talking about profit. And the sentence that talks about profit is this very first one. Whoops, it's a different color. 15-cent profit per glazed, 40-cent profit per jelly. Okay, so I'm going to write that. The profit he makes is off of 0.15 times the number of glazed donuts plus 0.40 times the number of jelly donuts. So there's my objective function, which I will use at the end. Now let's do our constraints. Again, it doesn't appear if there really is very many constraints, okay? But there is. Just got to read carefully, and you got to also use some common sense, okay? So let's look at the rest of it. A customer wants to buy no more than a dozen, okay, and wants to try at least one of each kind. Okay. All right, well, let's start with the first one, no more than a dozen, okay? That means that the number of glazed donuts, right? X, the number of glazed donuts, plus Y, the number of jelly donuts, cannot exceed a dozen. A dozen is 12. So it must be less than or equal to 12 donuts, okay? So now I'm going to go ahead and I'm going to do this again where I solve for Y. And I get Y is less than or equal to negative X plus 12. We're going to go ahead and number by 2's again, since we know that 12 would be off the chart. So 2, whoops, I don't want to fill them all in. 2, 4, 6, 8, 10, 12, 14, 16, 18. Same thing this way. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so let's graph that first one. So 12 is the y-intercept. It's going to be between 10 and 14, so right there. And the slope is negative 1 over 1, so that one's pretty easy in every single corner of the graph. Even all the way up here, even though it's not possible for us to use that information because that would be negatives. So now I'll go ahead and connect those. All right, and it says less than, which means it cannot include, therefore, anything above that line. So none of those areas there, only the things below, okay? And then we have one more restriction that's written for us before we have to use our common sense ones. And that is that they want to try at least one of each kind. So at least one jelly and one glazed. So those restrictions are pretty easy. So the second one is going to be the number of glazed donuts has to be greater than or equal to 1. They want to try at least one. And the third one, I'm going to write that to the right here. The third one is that the y must be greater than or equal to 1. So those are both going to be Hoy and Vux equations, remember? So this one's a Vux, vertical line drawn through 1, which 1 is going to be kind of in the middle like that. That's going to be a little tricky to spot. Kind of running right down through the center there between 0 and 2. There we go. And it says greater than that. So that automatically limits us on the negatives here, here, that little sliver, and that little sliver has to be greater than. And then the y1, same idea. So it has to be greater than 1 on the y-axis, which is right there. So I'm going to be able to draw a line this way, halfway through 0 and 2. All right, so that's going to just put a little tiny restriction that it can't be anything here or here, okay? All right, so that narrows down then, and obviously this one here, okay, because it says below. So it can't be, it has to be greater than that line, that horizontal line I just drew in. So that's going to create our feasible region in this range here. Right there. Whoops. Sorry, I kind of went below. Okay, so you got to pay really close attention to where those intersections are, okay? So this is the hardest part right here, is identifying this little areas. Right here is a point as a vertice. Right here is a point on the vertice of a vertice. And way up here is a point of the vertice. So they're not kind of right in the corners, which makes this a tiny bit more difficult for us to determine. So I'm going to go ahead and write in those coordinates. And you'll notice I didn't do the restrictions on common sense that x has to be greater than 0, y has to be greater than 0, because this did it for me. Not only do they have to be greater than 0, the baker or the customer wants at least one of each, okay? Okay, so I'm going to write my coordinates then. This one right here looks to be 1, 1. This one right here would be 11, 1, because 12 is right here. So 11, 1. And then this one up there is 1, 11. So I'm just kind of barely switching where I'm plugging some things in here, okay? So now I'll go back to my profit equation, and I can use my calculators. What if the baker, or what if the customer only did one of each? They didn't say they had to do a dozen. They just said they don't want to do any more than a dozen. So what if they just wanted to try one of each? Well, obviously the baker's not going to make very much. Okay, that's 15 cents, that's 40 cents. So he's only going to do about 55 cents if the customer only wants to try one of each. He's hoping that the customer's still going to do a dozen and just do it in some different increments, hopefully buying more jelly donuts because jelly donuts make more profit. Okay. All right, so here, let me not use equal sign. Whoops. Sorry. Let me lock that. Let me get rid of these equal signs. I probably should just use little colons or something since I'm going to be checking them with an equal sign. So, all right, so for this one, we're going to assume that the customer wants 11 glazed and 1 jelly. So altogether, that's going to equal $4.55. And then the last one, we're going to assume only 1 glazed and 11 jelly, which that one's going to turn out to be $2.05. Oh, sorry, I did it the wrong way. Oh, sorry. This one, I'm sorry, is the one that's going to make more. I was copying them down wrong. So on this one, if there's 11 glaze and only 1 jelly, he's going to make $2.05 profit. And then here he's going to make $4.55 profit. So clearly he wants to do this one. He wants to sell 1 glazed and 11 jelly for a total of a dozen. Okay? So obviously he's going to try to persuade the customer to get the jelly donut. However he chooses to do that. These are really good, or oh, these are new. Obviously to just try to get the customer to buy the thing he knows he's going to make the most profit on. Okay, so those are your notes, those are your examples. I am going to send you some extra practice with 4 more of these type of problems. There's only 1 on your homework, but these are hard and kind of tricky to identify and narrow down the constraints. So it might be kind of good for you to be able to see some other examples. So I'm going to send you that, but I will do a video with at least 1 more example from that worksheet.